Good morning, everybody. This is Yasura Singh speaking from Bharat, India, addressing this file to whole world. This is regarding spreadsheet. There's some short is, I think, and started yet. Let us start. Let me wait, no problem. Let this start first. I'm not getting video indication here. Okay, it's coming. Again, I say if I could not speak last time, I say good morning, everybody. I say Nasura Singh is speaking from Bharat, India, addressing this file to whole world. This file is very much specific, based on references from internet. This file title is Solar System. Dynamic file. This is equilibrium, etc., etc. This is something very specific for everyone because it's not civil engineering, but because I have to reflect calculations as I promised to you, calculations on Excel, and this is very much important file to an extent spreadsheet is concerned. That's very important point. Now this file, you can see I have written title as solar system. You can see solar system, dynamic calculations, details, and this was somewhere last year, but I just revised this for your reference because last time when I did it, I included this file on a video, but I could not project this file here except references, but now I'm sharing it through screen share, so I am not displaying my face but file face itself. Let me show you this file first. This is starting from here and going up to here 19s here S1, and vertically if you see it's not very long file, it's a small file, and this file carries many calculations here, many calculations. There's no control in this because everything is taken from references, and then there are certain notations here which I'll explain to you. These notations I'll first explain to you and then we'll continue on this file. I'll just blow up this for this purpose so that you can see clearly. You should clearly see this. I will not, I'm just expanding it so that you can clearly see what notations are. Before going further, I am giving this notation so I will clear to you, and I don't want to make this very long video, just I think within an hour to complete that. This video and this exclusively for solar system calculations. What is that? Now before going into details, I like to give you notes of this. Now what notes are? You can see these notes yourself. I'll read them, I'll blow it further so that you can clearly see them. This is noting here, Now note is that it says that this above table gives information pertinent solar system based on various references used from web. So this not mine, actually I'm just using calculations, but you can say sizes of system, relative astronomical information, you can say permanent astronomical information, you can say relative positions of these planets in relation to sun are have been taken from various sources. I'm not disclosing the sources. You can search on web, you can find on number one note is that solar system comprising of various planets works in dynamic equilibrium. I'll tell you what's dynamic equilibrium. The number two is all planets are revolving around their respective axes continuously. Number three, planets other than sun are also, you may call sun a planet, but I'm just saying planets other than sun are also revolving around sun with defined velocities or speeds. Number four, how many days does one planet consume to move around its axis are indicated. And number five is how many days does one planet consume to move around sun are indicated. Around sun means orbital movement. Number six, diameter and volume of each planet is indicated. And number seven is each planet's own rotating speed and speed around sun. Orbital speed, we call it, are indicated. Eighth, propulsion force. Propulsion force produced by each planet except sun because of orbital movement is indicated. Number 9, respective centrifugal forces are also indicated. Number 10, parameters. Parameters respecting sun are indicated separately because sun does not rotate around itself but only on its axis. Then 30, you can say, actually let me little reduce this so that clearly I can read this. So okay, it's okay. No. So it was, Earth rotates is number 11. Earth rotates on its axis at 1636 km per hour and around sun at 108,088 km per hour. 12. Escape velocity of sun is 223,720, that is 2.223720 km per hour. Means there exists no planet that can face sun's self-revolving velocity. 13. Diameter of sun is 1.391 million kilometer. 1.391 million kilometer. Whereas Earth is only 12,500 kilometer in diameter. 14. Amazingly, sun's internal propulsion force is enormously number of times of other planets' propulsion force. Then 15. This number varies from minimum 47 to maximum 78581. What is that? Propulsion force. This number varies from minimum 47 to maximum 785. Minimum is 47, that is propulsion force times, and that is 78581 for Jupiter and Mars respectively. So for Jupiter is 47 times, that is I say then amazingly sun's internal propulsion force is enormously number of times of other planetary propulsion force as 47 times for Jupiter and 78,510 times for Mars respectively. For Earth it's only 3631. Now 17. Earth is moving around sun at rate of 107,838 or more. You can say 1.078, 1.07838 lakhs kilometer per hour, or you can say 107,838 or 0.1078838 million per kilometer per hour or more, which is the highest planetary speed around sun among all other planets. 18. If some missile or rocket attacks surface of Earth from space, Earth could be jeopardized very badly. Right. 19. If some rocket is launched from Earth for a trajectory to enter space and then commanded to return to Earth to attack it, Earth can be endangered and its existence can be challenged by some devil's might. 20. No vehicle could be designed and built to reach sun. No vehicle could be designed and built to reach sun, and even if it reaches sun, it doesn't look feasible to have a speed of say 2.5 million kilometers. Sorry, it's not million, it's kilometer. Let me correct it. There's an error. Million kilometer per hour. Sometimes you find errors, so you have to correct them immediately. So 0.5 million kilometer per hour when it reaches sun. 21. Illumination power of sun at sun is 3.83 into 10 to power 26. 3.83 into 10 to power 26, or this is 383, and you can count them, you'll find the watts. It's impossible to be digested by planets. Okay, So we go back to other one. Let's see what's this. Then I say that is 23. It's 22. Earth produces propulsion force at 6.08 into 10 to the power 26 watts, of course, or this power till to tons kilometer. That's not the force. Tons kilometers per hour, and that illumination power was watts. It's 10 kilometer per hour, highest among all planets, and that's this is except Sun. Now 23. Solar system. Solar system imaginary envelope volume is 5.24 to 10 to the power 32. Solar system imaginary envelope, not envelope, imaginary envelope. Whole solar system, if covered by some envelope or sphere, measure sphere, you can say that's 5.24 into 10 to the power 32 kilometer cubic. This volume, cubic meter, which surface is illumined by sun. That is volume. Solar system imaginary envelope surface is 3.1416 into 10 to the power 22 kilometers square. This is an error actually. It should be square because it's surface. So I correct this. It should be square, not cubic meter. Sometimes copying paste also makes a problem. So it should be square. Which surface is illumined by sun. 25. Sun's internal propulsion force. Sun's internal propulsion force is 2.21 to 10 to the power 30 tons kilometer per hour, which while all planets moves on total 5.32 in 10 to the power 28 kilometer per hour tons per hour. 26. Sun imparts luminosity. Luminosity means power of illumination, can say. Sun imparts luminosity to all planets at 6.3 to 10 to the power 13 watts per kilometer square of its surface area. And then you can say 27. Illumination to planets exposed surface area is 0.5 because it cannot illumine immediately the whole or complete surface. Projection is there. Let's consider 50% of all planet surfaces. That's 1.26955 in 10 to the power 11, and that is this much, 63477500 kilometers square. Okay, now that is area. Now let's say 28. Conclusion per above data suggests the sun with its internal propulsion energy 2.21 into 10 to the power 30 tons kilometer per hour presumably transfers to other planets as 2.4 each, like this, and then 29, which is 29, since energy cannot be destroyed, this reformed energy spreads into sun's surrounding spaces, reaches to other planets to create buoyancy effect. Buoyancy means because planets have no foundation, no columns, no beam. How they are doing? They are doing because of their rotation on their own axis, as well as orbital movement, and this energy the sun is transferring to them through its power that creates certain force probably, and that force keeps them in equilibrium because they are in two movements. One is it's axial movements, and other one is orbital movement. In both movements there is a balance, a dynamic balance, and that additional force is there, so that this additional force keeps by reaction each planet in equilibrium position. Then say planets self-developed propulsion force are used for their own propulsion forward movements in orbit. So this also there. This planet self-developed forces are used for their own perpetual and forward movements in orbits. And 31 is sequence of orbital speeds. Earth is highest. You can say number one because of orbital speed. I'm talking. Earth is number one. That's highest. Mercury is second one. Venus is third highest. Mars is fourth. Saturn is fifth highest, and Jupiter is sixth highest. Uranus and Pluto lowest. So this we will discuss according to calculations. I've taken all this. Now 32, Venus has longest day. That's 243 Earth days. Means when you cover 243 days on Earth, it's equivalent to Venus day. Mercury is second longer, that's 59th days on Earth, equal to 1 Mercury day, and 39% of Earth day means we have 24 hours, so about 39% or 40% you may say, about 9 something hours, that is Jupiter's day. So you say Jupiter days are very small and shortest one, so then you can say 33 worked out based on, I have worked out based on 2.3 into 10 to the power 25 radius number of solar systems based on solar system volume is 25% sky. You can say sky volume cover. So how many solar systems it could be? This is number of 2.43 into 10 to the power 7. This is just notes I have shown to you. Now we'll go to home. We'll go to home of this and we'll see how it's working. Let us see. I say home is here now. Now it's important point I've started so far, just giving you brief information about actually what I'm talking of. I think, and after having collected information regarding sizes and their speeds, etc., and number of days, etc., I worked out on Excel. Why I worked out, I'm going to discuss with you, inform you. Title is Solar System Dynamic Calculations, and now one point here, and then the other one is 19 here. This is number of columns I use for calculation purpose, and you can say now calculation I start to explain to you what is that. Solar system equilibrium is solar system equilibrium, and that is dynamic parameters, etc., etc. That's what it is. And now what are these columns? You have to understand. First is this first table. You can see this fit table, first table here. Then there is very small another one. This here, and very small one. I'm just keeping it little open so that you can get full value. So percentage of planet relative to sun's diameter. If you take diameter of sun, then what is percentage of that diameter other planets are. Other one is names of planets. Then rotation at axis perpetual, rotation at axis. Then orbit or rotation around sun, and then planet diameter kilometer, axis speed at surface, then sun diameter is this diameter of sun, then distance from sun, distance of planet from sun, orbital speed around sun, and then average density in centimeter cube, and then average volume, and that's in kilometer, so cubic kilometer, then average density in kilometer cube, that's average density, and planet mass, and planet's propulsion force, then centrifugal force, and then how many times propulsion force, that is sun's force, or other planets, how many times is that, how many times sun has force if you compare it to other planets as we discussed, and sun's self-planetary motions relative propulsion speed, and planet's distance from center of sun and planet's surface area. These are columns that I have used in these calculations. So let's now jump up and see according to that, if you understand what I mean, I can now move further on this just to see. Now here is here is percentage, which I said percentage. The planet's name are there, then days are here and days are here, and then you can say kilometer it is. Days, when I say days, mean how many days it takes for one planet to orbit, and then you can say rotational rotation at axis perpetual, that is 1 day on its own axis, and this is orbital rotation. So there are two types of days. First is perpetual rotation, means days on its axis and days around sun. Two different timings are there. You must try to understand that. And we say planet dia, this kilometers, axis surface, axis speed at surface kilometer per hour, sun dia is in kilometers, dia from sun is kilometer, like that units are there. Now let's say which are there, it starts, let me just do little small so that we can understand. Now let's say I think it's better to just keep it blown up so that you can be clear. It can be clear to you what I'm showing to you, and that's important, Now we are here. I say diameter of sun, it says column is sun dia, there is a diameter. This is Mercury is 30.35% of that dia. This is Mercury, then Venus, then Earth, then Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Mercury, Venus, Earth, on which we are, Mars, Jupiter, Saturn, Uranus, Neptune. Now what it says, 0.35%, 5% dia of Mercury if you compare it to Sun, 0.86% dia of Venus if you compare it to Sun, 0.9% dia, that is dia of Earth if you compare it to Sun. You can see 0.49% dia of Mars if you compare to Sun, 10.28% dia of Jupiter if you compare to Sun, 8.67% dia of Saturn if you compare to Sun, 3.67% dia of Uranus if you compare to Sun, 3.56% dia of Neptune if you compare to Sun, and 0.1709% dia of Pluto, which is very dwarfed if you compare to Sun. These are diameter percentages. How you calculate, I'll show you. I'm just telling you first what is there. Now we go further. We will talk these 1, 2, 3, 4, 5, 6, 7, 8. 8 planets around Sun, and 9. It's also 1, 2, 3, 4, 5, 6, 7, 8, 9 planets around Sun. So if we may, well, I'm not changing any format of this. Let it be as it is. Mercury is a planet which is now, how many days on its own axis it takes? That's point. It takes 59 days. These we are comparing in connection with Earth, and around Sun, and so this is on its own axis. We see days, when we say days, it's on axis, so it's 59 days on its own axis, for it's compared to Earth. So here I'm saying Earth on its own axis, it takes 1 day. So when days are constituted, 24 hours are constituted. So that we call 1. So in relation to that I'm talking, and it takes 365 days around. When it moves in its orbit around Sun, it takes one whole rotation in 365 days. In relation to this, Mercury takes 59 on its own, 59 days, and it takes 88 days around Sun orbital movement. And when it is here, Venus हाँ जी, क्या हाल है सब?
कैसे हो?
बस सही है, सही है।
आ जाओ, बैठ जाओ।
नमस्कार जी।
अब कैसे हो?
बस ये फर्स्ट क्लास है बस।
वो करने लगे?
वो थेरेपिस्ट के पास जा रहे हैं ना अभी, रोज 3 दिन जा चुके हैं
तो
थेरेपी
यहाँ
के।
पे नहीं आता थेरेपिस्ट?
पैसे ज़्यादा मांगता है यहाँ आने के।
अच्छा,
हम चले जाते हैं।
और यहाँ घर के
1500। अब क्या करेंगे, रेट्स हैं।
काफी नहीं ना, आपने एक के आगे
नहीं कोई बात नहीं, बैठिए आप।
नहीं, मैं बाहर बैठा।
करो, आप करो, कोई बात
फोन
नहीं है।
नंबर चाहिए था मेरे।
किसका?
प्रेम सिंह का।
प्रेम कर लिए?
हाँ जी। आप कैसे हो?
So sorry for disturbance. I say Mercury takes 59 days on its own rotation, and it takes 88 days around orbital rotation. Similarly, Venus takes 243 days on its own. These days are Earth days, 243 days on axis and 224.7 around Sun. And this is 1 here, and this is 5 here, and this is Mars 10.1.025 around on our own axis, and 687 around Sun. And then it is Jupiter 0.3882 on its own, and 4380 around Sun. See how many days? 4380, more than a year here, because 4380 days, we have 365 is 10, and not a year, it's more than 10 years. You can just see 3, it is 4380. If you divide by 365, and you will just take here itself, I think is, let's say this consider, let's say this is blank cell, I can consider delete it later on. So this is 365 divide 365, so I can say this way, this is plus 4380 over 365 here, and this is plus 4380 divided by 365, so you can say how much? 12. It's 12. It's interestingly, it's 12 years. Means Jupiter takes 12 years around Sun orbit, in Sun orbit, while in Earth it's a 0.38 only, 0.388. That's the difference. And you see Mars, which takes 1.025 on its own axis, it takes 687. Again, you can say how many it is. We can see how much it is. Plus 687 divided by 365 is 1.88 years. You can see that. So again, Saturn is having 0.4167 of its own, and same 12 years, 4380 around Sun in orbit. Uranus is 0.7083 on its axis, and 3660. We should calculate this and see what does it mean. You can say plus, I say 36 divided by 365, so you can say it's 84. 84, which is a very big figure. 84, that's it. And if you take like this, other one, Neptune, and this also is very big. Neptune is about double of that, so 62, that means less than double, and it's 90, is 3 times than that. Let's try how much it is, just to for clarification. So I say for for Neptune. This is this one divided by 365, so it's 165 years. I take it off, and you can say here this is D13 for Pluto dwarf, D13. So I take D13 and I divide by 365, which is here, and this is 248. See difference here. That's what's important here. So we should understand this important engineering information, space engineering. Actually, this is when I was young, I was studying in engineering. We should astronomical chapter was there, relative positions of planets. So this is same, means that this is a dynamism, while relative position at one time. This is so. Actually, it is survey. It is space survey, and we used to understand astronomy, and this is what it is. Now let's go further. This is what we did here, and let me see how it is working. About it's now 31 minutes, so let me continue. I can finish by soon. Now this is about days. We have talked of days on its own, on rotation, on axial, and this is around sun, that is orbital movement. Now let's do something else, and this is planetary dia, kilometer unit, and Mercury is this one, 4850 kilometer. Venus is this one, 12,000 kilometer. Mercury is 4,850 kilometer dia. Venus is 12,000 kilometer dia. Earth is 12,500 kilometer dia. Approximately, I'm telling. Mars is 6,790 kilometer dia. Jupiter is 142,980 dia. 142,980. I think this is a bigger one. Then Saturn is just little lesser to this, as 125,36, 120,536 kilometer. Uranus, which is 51,118, not that big. But if you see Neptune is 49,500, and if you see dwarf planet Pluto is 2377. So which is the smallest? Pluto is the smallest here. Pluto is the smallest. After that, if you jump onto, you will find Mercury, that is a little next to Pluto, as a higher one. And if you go to down, then you'll find Mars, and then you will find Venus, and then Earth, and then you will find after 12,500 it is Uranus, and then you will find Saturn and Jupiter, like that, like this. So now we see axis speed at surface. That's very important. Kilometer per hour means what speed at surface on which you sit. We take, for example, Mercury is there. I'm just giving you information how we calculated that. I'll give you next rotation. So this is Mercury is 10.7604 kilometer per hour. Venus is 6.4648 kilometer per hour. Earth is 1636.24. Means we sit on Earth, and Earth is moving at this. We never feel it, we never discern it, but fact remains that Earth is moving on surface at this speed, which is higher than the speed of a international flight, as well as it's somewhere near supersonic flight. Then Mars is 867.131 kilometer per hour. Jupiter is 48,213.1 kilometer per hour. Saturn is 37,867.5 kilometer per hour. Uranus is 9446.58 kilometer per hour. Neptune is 9719.3 kilometer per hour, and Pluto is 48,617.617, very smallest. This is what we are talking of here. Now we go to kilometer. Actually diameter. We are talking diameter. Mercury is 1391020 diameter. This is for sun. Sorry, this is for sun dia. So 1391020, 1,000,000, 1.391020 kilometer, million kilometer dia, That's 139, 113 lakhs 91,020 kilometers dia of sun. I have taken everywhere. These are not these dia, these are sun's dia. So just for clarification, I should change little so that you should not confuse. I just club it with this so that the confusion does not stay there. Actually, you may confuse otherwise. So this I club it in this group. This is different, the sun's dia, so that you may not confuse with that one. Now come on, distance from, because already we have taken their speed and their all days and kilometers. Now sun dia is this. Now distance from sun, that's important point. Distance from sun of these planets, let's say Mercury. Mercury is, this is from sun, this much, you can say 5791000. This 5.79 crores, and this is 10.82 crores. This is Venus. This is 15 crores. That's Earth. Everybody knows Earth is located 15 crores kilometer. Crores, when I say crores, this means, this says 1 crore is 10 million. So when I say 15 crores, 150 million, and then it's a Venus 108 million, that's 57.9 million. And this is now Mars is located at 22.799 crores, so 227 million. And then like 77.85, this is Jupiter, and that's crores 77.85, and then 142 crores is Saturn, and then like this others and others and others. I mean, you can read yourself what's here. And Earth is here. Earth is 15 crore, and which is very important for us to know. Now orbital speed we have to find. Orbital speed, that's very important point for which we are all here. This says Mercury's orbital speed is 87,175 kilometer per hour. Venus is 63,437 kilometer per hour. Then Earth is 838 kilometer per hour. That's Earth, 107,838 kilometer per hour. Mars is 43,556 kilometer per hour. Jupiter is 23,287 kilometer per hour. Saturn is 42,877 kilometer per hour. Then Uranus is 12,260 kilometer per hour. Neptune is 9,771 kilometer per hour. Pluto of 6,501 kilometer per hour. Then we say average. What is that? Is this now gram, centimeter per, this average density. You see, we have taken this density from somewhere sources, and same we can say, we can say that we can just density. This is if you can say Mercury, this is 5.43, Venus 5.24, Earth is 5.51, and Mars is 3.93, Jupiter is 1.33, Saturn is 0.06787, Uranus is 1.27, Neptune is 1.64, Pluto is 1.27. This is, and then cubic kilometer volume, that's what is the volume. So this is here, this is Mercury is 5.97 10 to the power 10, and Venus is 9.05 10 to the power 11, and Earth is 1.02 10 to the power 12, Mars is 1.61 10 to the power 11, Jupiter is 1.53 into 10 to the power 15, and Saturn is 9.17 into 10 to the power 14, Uranus is 6.99 into 10 to the power 13, Neptune is 6.35 10 to the power 13, Pluto is 7.03 into 10 to the power 9. Kilometer, this is tons per cubic means. This is something else, and that is average density in you can say volume. This is, and this is average density in kilometer cube. No, tons per kilometer cube. Sorry, I forgot to speak ton. Mercury 5.43, so it will be same, except we change these units because of kilometer, and the kilometer cube means 1 kilometer. When you take meter, and centimeter and kilometer relation, we got different value here, and also ton is here. So we can say here planet mass, like that, and we say planet mass is there, and when we go this way, we'll find planet propulsion force, then centrifugal force, then how many times etc. is propulsion force, sun self-planetary, planet motions, and all these we have calculations. Now important point is calculation, how to calculate this. That's important here now. So I just explained to you what that was. Now what actually we did here. This is kilometer, diameter of sun 1391020. That's kilometer, and that's diameter of sun. So this diameter we are given, and we have to understand what you're talking of. I am having here, you can say this diameter, that is, planet diameter. Now how to find that? How many percent is that? That's the easy formula. Is we have two values. One value is here in this cell, one value is there in this cell. So we have to, relate this to, what is this? E5 here. Let's say, what is E5? You see, E5 is the cell formula, E5 divided by G5. E5 divided and multiplied by 100. So we get this percentage. Then we get here this percentage, that is for Venus, and then we get for Earth, that is this percentage, then Mars this percentage, then the Jupiter this percentage, Saturn this percentage, Uranus this percentage, Neptune this percentage, and Pluto this percentage. That was the reason that I put everywhere Sun here, so that percent could be computed out without any problem. This was one point. Now this information is blank, so you can say I cannot formalize this is here, you can say these are blank, this is blank, this is blank, this is also blank. In fact, this all here is also blank. What is the work out of something, but that's not something, so leave them. This is actually, we got days, we calculated something of that based on some information. For example, we say 165 365, like that. So that's something else, we got this information. So this is values here, all now kilometer also, this is given somewhere and I took from here. So these cells are, you can't change them, so you may say these are editable. In that way I can say that I may put like this, so that you discern differently. Otherwise there's no way I can say these are not formalized cells. Different type of formula it is. It's not exactly, you may say or you may not say that. Same thing. Example is here 16/24 I'm taking just for some reason. So these are all, now kilometer per hour. Here kilometer per hour we have to find. How to find that? That's point. Here I say, for example, Mercury, I'm saying pi, this value of pi, E5 is, this diameter is pi d over C5. What is C5? C5 is the days, each day, and then 24. Got it? We are having a speed, kilometer per hour, means we got pi's value, pi E5. E5 is day, pi d, that's circumference, and divided by C5 here. This is number of days, so we got each days and per 24, because 24 hours are here. So this is kilometer per hour. And this is not only for this is for this, 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 and this is for this. So you get kilometer per hour according to formula. You cannot change it because this is a formula. Similarly here, kilometers. This is sun we have seen, so you cannot change this also. This is we may change, if just for your reference I put it, because this is not formalized. So I put this, this only 695522, so that's whatever kilometer we find this. So that's also I say I put like this information. Now this was sun dial, distance from sun. Now this is important point, distance from sun, how in distance from sun it is. This is also given 10 to the power 6. So if you see formula, only 10 to the power 6 is there for calculation purpose. and let me see if this is right or not. This is a distance from sun, because I taken this from some from 10 to power 6, whatever's there, 8 8 6 8 8 9 mean all there are there. So this is also, you can say, I can put them like this here, so because these are not formalized one, this is informative one, so I put them as well. So you can say, you are seeing a part where the edible cells are non-edible. Now kilometer per hour, that is equilibrium. Now seeing orbital speed, distance we got, orbital speed, that's important point. Here its formula. Its formula here. That's 87175. That's the example how it's coming. It's coming because of pi, has pi. Then I say distance from sun, and that is g5. What's g5? Kilometer. That is, kilometer is dia of sun, so we have to see half of that for radius. Diameter is this, so for radius we have to take 0.5 into g5. G5 is dia, and then we have to add h5. H5 is this is h5, means up to, we have to take distance from sun. Distance from sun is this, so we have added distance from sun, and we have added a half of sun diameter, and that's total center to center, that, and then we divide by d5. This d5 is number of days, d5 is number of days, as 365, so we divide by, so we get per day, and then 24, so we get this answer 87,175. Similarly, it works for Venus in same way, it works for Earth in same way, it works for Mars in same way, it works for Jupiter in the same way, it works for Saturn in the same way, Uranus, Neptune and Pluto. Like this, it works. You can see, again I say you, because maybe my cursor didn't work. Mercury this one, Venus this one, Earth this one, Mars this one, Jupiter this one, Saturn this one, Uranus this one, Neptune this one, and Pluto this one. This is what we got formalized, so I can't touch this cell. Now density is also not formalized, so I have taken density from some information, so this is also not, it is also editable. If you wish, you can hold on 5.43, this is all editable. Yes, this is also editable, this is also editable. This is J11, and J11, there is J11 is here. Oh, because they are same, so it's same value. So I remove this, and I take like this. So this is J11, this is not. So these values are, I have taken for editable purpose, and this is J1. Now we go this way again. What is this cubic kilometer? That is volume. Now how to find volume? We have how to find volume of this. Now let's see this. 4/3 pi we know due to r cube. We have this pi E5. E5 here is E5, which is diameter. So we divide diameter by 2 to find r, and so, and this is cube. This means this everywhere same formula is applicable. Everywhere in this same formula is applicable. You can see that once again I show to you. This is E5/2, then E6/2, then E7/2, E8/2, E9/2, E10/2, 11/2, E10/2, and E9/2, E10/2, then E11/2, E12/2, E13/2. So this is also same. Now if I go there in this, if an average density they've got 5.42, so we converted centimeter cube to kilometer cube, and that's this formula, then 0^9. So you can say J5 is gram centimeter cube per centimeter cube. J5 this divided by 1000 to convert gram to kilogram, centimeter cube it is, then centimeter cube divided by 1000, then 1000, it's an error I think, tons per kilometer cube. So centimeter to kilometer, grams per centimeter cube. So I say this is means we have to convert to tons. So this is tons per kilometer cube. tons per meter. And the way this is 100 into 100 into 100 into sorry 100 into 100 into 1000 some plus matter of things. Now maybe something wrong here. Let me see. That's what we have to understand. Means maybe if we make some mistake, we have to see. Kilometer is 1000 into 1000, so it's okay. That's kilometer. Tons per, we have to convert it tons. 100 into 100 into that is gram. The centimeter converted to 100 into 100 into 100, that is centimeter to meters. Centimeters to meters and meters to kilometers, so it's okay. Centimeter to meter we convert 100, and then we divide it for tons, and so 1000. So that's what this can be checked. So this is completely, you can say, let us say this one here. Then we go down, also same, only J is changing, and that's what is required, you know. Now we see similarly, you know, this is actually I'm not finding. Why I'm not finding? I think well, I think there's some problem. It's gone. Why it's not available? Well, what's the reason? I don't know reason why it's not available. I don't know. It's okay. So I'm finding this. I'm finding this, and so you know there's some confusion. Now I'm going to, you can see here. So we have gone up to here, this formula. Now we are here. This is parameters. This is planet mass. What is planet mass? You see K5 into L5. K5, K is cubic kilometer, K is cubic kilometer, and L is average density. So what you do, this K5 into L5 is that formula to get tons. So this is tons now. Say here 5, 6, so only those are changing, and you got that. Then you find planet's propulsion force, that's ton kilometer per hour. That's important now. See how much? M5 into I5. M5 is ton and I is kilometer per hour. So ton kilometer per hour, this is that. And you see it moves like that, and this for Earth actually. That's why I put this bold, where speed is 10787, which is here, and this is density. And that's all planets separately. Same formula we used, and we got it. Now tons hours, centrifugal force. Why said M5 is ton. I5 is kilometer per hour. So this is ton kilometer per hour square. Here I5 square. That's formula, and that is, you know, kilometer per hour. This is. So M5 is tons, and then divide by E5. E5 is, if you see what is E5, hold on, I go back to E, and this is E is kilometer, size, so that's size. So means size. So this is M5, that's tons, this total weight tons, mass, and you can say divided by W, you know, we had to find tons hours. So else this is I is, you know, per kilometer per hour square over E5 is set size over 2. This formula we applied, and we got centrifugal force a half, and we square over that, whatever this is, that dot. We got this for every case. This we got here, and we got here and here. Now what do you say? How many times propulsion force sun over other planets? So how many times this is? N7, in N7 we got this one force, and N7, this is for, we divide by N5, N17 by N5, N17 I'm saying that is somewhere else, and that is that N17 is here. That's planet's internal propulsion force on this one, and we say how many times is this force, and then we say n17 divided by n5. n5 is for this planet, so that force of sun is divided by force of this planet. So how many times it is? We got 78,211. This formalized one, like that others and others and others and others we get. That we n7 we keep constant because that's of sun, so we get this result. So this is also unredictable. Now what is that? Percentage wise what it is, let us say what is percentage wise. n5 we have here for planet and n7 is the sun, so this is percentage wise, is the all is percentage wise this. So this is for information, percentage wise. And this kilometer, what is that? Planetary distance from center of sun, and that's this one, this planetary distance, h5 plus g5, h of the kilometer and g for that, and half. So you get this distance for each planet. These are planetary distances of same formula we use, and this is same, so we use this one. And then kilometer square, so it's easy, means we use 4 kilometer square, that is from the requirement is planetary surface area, planetary distance, planetary surface area. So this is surface area 4 pi r square. E5 is divided by that, so get the radius, and all this is that one. So what we say, we got this. Now we move on to other one, that is we want to value of sun. Let's move it to A. I'm sorry, not A. This is here sun. Now we have another table that is for sun here. So 57 minutes over, no problem. We're talking of sun. Now sun, here is let me first see why I'm taking so, or it's required, you cannot say that. So sun is dia, this is that we already took from there. Well, we took from there, this is 1319. We have taken from G5, so it's okay. G5, this means G5 must be free. So this is G5 here, so it's okay. It's okay because already we are keeping it, or we could do something else also here rather than doing this G5, because I'm taking here. Now why not try to change this? Let's see how to do it. Because we make it a different way, because I'm using G5 there. Let me see how to do it best. Let take this one G5 and keep it white. Let's I think let's make like this. Let's paint it first. I mean to say format painter, and we do like this, you see. So it's okay. What I do now, because I want to have this formula here, I want to have this, I have to do this rather than doing that way. We can do this, then we can do this again, then we can do this again, just a little change in format, and do it again, and we can 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 do it again. Oh, sorry, just a minute, error of sign. So we can do it again, we can do it again. So that's what it is. So G5 is now free cell, and that's why I've taken there. Let me say this is bold and keep like this. Okay, fine. And this is now like others. G5, as I said here, this is G5. So that has come here. So this is now formalized one, and volume is, you can say 403. This diameter r cube, that's one also formalized. Area surface 4 pi r square, so this also formalized because there's a C17. We are using C17 here, we are using C17, so it's okay. Parameter pi d, and so this is C17. So this parameter also there. Density in gram 1.41. It's very very light sun. It's how we do this one because this is also editable. You can change it, but mass is this is formalized one. 1.98. I think 1.98. This is mass is value. How did it come? You know, 98 and 10 to power this or this and this 1.98 time mass. This means I must taken this value from somewhere, so I can't change it as well. So that's then we can say so this is raw. Then it is escape velocity. You can say it's formula 1.989 what I say. So we should take it also this one escape velocity. That's simple. That's also given somewhere. I not taken my way, so I can say escape velocity is also editable. It is there. Luminosity is also this is also if not formalized, so I can take it like this. Luminosity there it is just formalized J17 over E17. This is here surface area, so it can't be formalized. Let me say now planet mass. This is also at 7 planet internal propulsion force as 17 over size, so I got this also formalized. And then we can say planetary propulsion force of sun, that's 2.4. this also formalized, cannot change, and planet surface area is formalized, so formalized cannot be changed. Now a velocity more than 2.5 million kilometer per hour, I can say per hour is required to escape sun from its absorption of vehicle. That's we already discussed. And now what it says, let's say escape velocity, then it's okay, I define that. I'll say lowest velocity. What's the meaning of escape velocity? This is lowest velocity which a body must have in order to escape gravitational attraction of a particular planet or other object. Velocity much more than escape velocity is required to be back from sun surface. This means if your velocity is less than that million, as I said, that escape velocity is 2.2. If your vehicle is less than that, this will not come back from there. This will go into body of sun and dissolve there. Now this definition of velocity. A solar system, I think this last table had solar system volume, envelope or coverage, imaginary diameter, this is that one, this is 10 to the power 11. Then radius, this imaginary diameter, you can say I put this like this. Then radius, and radius is 5e d to 0.5. I can't change. 3.14 is pi. Remember the imaginary envelope is this. That's also 4 over the pi cube, so this is okay. And then volume of sites, so this is 2.58. This is also formalized, and therefore you can say this is also formalized as percentage of solid space. And then negligible illumination envelope is also formalized, so everything is finalized here. Planet force is also finalized. All these are formalized, so you cannot change it. So solar system volume envelope, it gives, it says radius is this, that is, and pi, pi, all these are formalized, so you can understand what we are talking of. And then you can say I've given you what this reads with. That's also important. And in fact, to be very frank, this was very initially very precise information as much as possible I could get from various sources of internet. Maybe right or I can't claim, but how to work on Excel, how to tabulate, that is very important. I'm not claiming. Her important point is for Earth, you can say for Earth, what's the speed is. This is very important part here. You can say we have a very important part here, to be very frank. And also this is speed. That's also very important part here for us, because we should know. You should know what speed we are living in. That's important 2 points. Actually, I was interested to know this. Well, I try to explore this. I find more and more information of all planets. I spent a lot of time on this to find. So I said, okay, if I'm working on this thing, why not to do it more and more, more and more, more and more, and this engineering information or this astronomical information, you may say, astronomical dynamic information. That's very very important point, and I try to move on to that, and ultimately, I think I I have done something. I can't say it's absolutely perfect because nobody can claim that. I'm not scientist from space. I'm not astronomer. I'm not astronomer scientist. But just try to tabulate them to whatever capacity I have as a civil engineer, and I try to do that. And I think at least to understand how, to what extent these calculations be done. That's the important point here. My point is not that projection of world. It's just that we understand how to plot, how to chat in all this information, and you can work on this if you wish. This information is not means my personal one. This is sourced one. So we have, as I said, I already read these notes for you, and same is coming from this direction, and that's very important point, very important direction. I say I'll put it in big chunk now so that it's not difficult to read. Read the one. I think I scheduled in for 1 hour, and it's 1 hour little minutes, many minutes, no problem. And think you should be happy with something you have in hand rather than imaginary. I try to project to you something which is, though imaginary, we cannot see, and this is means you can say. I also try to give you a number of something else. Let me see what is that. Maybe I forgot before I skip lost it. University this and this. Surface area parameters is one which I'm looking for. Why was that? Let us see. Is there percentage of space, solids to space, volume of space, in the planetary propulsion force. I think there was something else I missed. Planet surface area, planet distance on subplanetary, or something else I missed. I am sure. What is that? It should not be missed away. Well, planet. I think I calculated something in this. And forever universe, and that's the universe when I'm saying numbers of solar systems at 2.3 into 10 to the power 25 1/4 sky volume coverage. It says percentage of solar system at 2.3 into 10 to the power 25, because already we have found the sky distance minimum from here as 2.3 into 10 to the power 25, and this I'll calculate this solar system sail and take 25% of that for this solid volume. So this is the one actually. If you see this important point, I say 4 over 3 pi 2.3 into 10 to the power 23. This is 2.3 into 10 to the power 23. I'm taking on safer side, so 4 over 3 pi 2.3 this r square, r cube, sorry, to find volume, and then divided by I21, and where's I21? This is 21, and this is, let us say, I21 is this kilometer cube. So 1/4 of that, this divided by this volume, 1/4 of that is saying, and we find here very good information, and that is here this is answer 2.43 into 10 but 7, that is number of solar systems in universe. That's could be, I'm not sure what number of solar systems which you think there are many solar systems in Brahmand, and this is so many You can't keep imagination if I am not wrong. This is 4.3 pi the r is that much, pi r cube, and divided by I-21, that's the one, and one, that's one I'm to say one solar system, and then 25% of that I'm taking. So it's okay, it's okay, it's very brilliant information. Actually I forgot where it gone, but now I've seen, and I written it somewhere here, I think. Worked out based on 2.0 radius, number of solar systems based on solar system. That's, I think, it's not coming in. Let me put in like this. So based on solar system volume of 25% sky. Okay, so this is same information. I think I turn what I said. That's the important point. And interesting, it is very, very interesting. My purpose was to not to research solar system, but just assume that what information based and what information I got, including this as much as possible. But I just try to show to you what best method can be used to include English chart tabulation. You can convert the graphics, the graphics purpose. Understand astronomical positions, and this is based on information available. Again, I say I'm not expert of this, but whatever related information I got, I include in this chart sizes of planets, their astronomical locations, and you can see their diameter, of densities, and their own movement based on their size that I calculated, because I got timings from sources, how one revolution takes how many hours. So based on that, I tried to work out two major speeds, and that is one speed is on its own axis, only when you complete one axis rotation, how many hours it is, including Earth. So you can say Earth is a relative position. Then you can say when every planet is moving around Sun, it's an orbital movement. So we got dimension, I mean to say, from center. For example, from Earth, I say 15 crore kilometers. Sun is, so 15 crore kilometer and half of Sun, because Sun is too big. It's 1.3 million. So if you compare to Earth, it's nothing. You see, it's very, very just see if you compare to Earth. I just take and the small calculations for this, just for your reference. Let's say, for example, let me say Earth here, which is I can say what I was thinking just now. I forgot. It was Earth is 12,500 kilometers, and you can say Sun is is 13. Let us consider 13, or let's take from here itself, means it is G5. I'm sure, yes, it is. Sun dia is G5. Yes, we can take G5 is that, and G5 is that, and this is Earth is G5, and Earth is E7, G5 E7. So we can say Earth is G5, G7, and this is no, that's wrong. This no, Earth is G5. It's okay. G5 is Earth, and E7, I think E or something, I don't know, E7 it is, let's see, E7, so it's okay, that's fine, it's okay. And this is kilometers, you can say, this is kilometers, and this is also kilometers. Now, why I'm telling you, why I'm interested in, I'm just interested now, how many times you have to keep more Earth so that it equals, I'm sorry, it should be this, and this with this, sometimes, no, wait a minute, this is Sun is there, so Sun is here, and Earth is here, alright. So what I say is this, let's say It's just this additional calculation it is. Now, my question is, if Earth die of Saturn, Sun. I'm sorry, why I'm making mistake today. I don't know. Sun. Let us say I divide this sun value, sun over Earth. Let's say sun dia divided by Earth dia, sun dia divided by Earth dia. All right. This is that. Let's divide now. 1. I'm just this divided by this. Once you see numbers, that's the numbers. This is numbers. What do you mean by that? Do you understand? This says, in this dia, which is sun's dia, this Earth dia, this is kilometers, there can be 111 Earths if available, and we keep them together, keeping adjacent to each other without allowing any gap. You shall need 111 Earths to equal sun. That's point here. That's very important point. You got my point. And if you see how many Earths can be accommodated in sun, that's another point. Let's see if I have volume of sun. Have I volume of sun? I think I have somewhere. Volume of sun, solar system, sun dia, kilometer, volume. Yes, volume is there. We have, this is D17. Let's say D17. Let's say put here D17. No, here I put, I think better. Otherwise, I see. Okay, D17 I keep for timing. I keep here. You can keep wherever else. So this is this is dia of sun, which is here. Yes, volume. This is volume of sun. Now we say Earth, that is here, kilometer or centimeter cube. I'm not finding where's cubic kilometer. No, it's kilometer cube, tons. I think kilometer square. No, we don't have that. Volume of sun we have somewhere else, not here. Well, I think it should be. How can it be? Kilometer per hour, gram per centimeter cube, cubic kilometer. Volume is there. Volume, yes, it's there. I was mistaken. So we can say cubic kilometer. That's volume. I can say this is the volume. And this good one, if I have, so that I'm talking of this, I put another mark here. So this is dynamic volume. Volume of Earth is K7. Let us say, where is that? Where was? I don't know where was. I'll put out that calculation. Where's that gone? Oh, sorry, K7. It should be here. Yes, it's here. K7, I see. Plus K7. So this is K7. You got it? Let's say it's a K7. This K7. So we have volume here. We can see this volume. Km cube, volume. I can see this volume, and also other one is volume. You can see here volume, and this is you can say this is volume here. Just to keep it lined, keep it bordered together. So now, how many Earths would enter sun to fill it? So let's see numbers here. I see numbers sun dia, and let's say plus. Or the same we can say, there's no problem. We can copy it directly and put it here. The formula is same. So you can say 438,652.1 Earth's can sun can accommodate. Number, say numbers. I can say sun dia or earth dia, this is that, and here I can just put in insert here, so that I can say here that sun over earth we divide, we get upon this, and number of earths, you can say earth numbers. Now I put here earth numbers in sun, earth numbers in sun, better, in sun it can accommodate this. That's what it is. You got my point. So I take out this is different type of statistics. Here you can say relation between earth and sun, better we write here relation sun earth relation sun earth relation sun earth size relation, that's I think is best what we can use, sun earth size relation, and that's important point, sun earth size relation. So we can just say this is something different information. Sun earth size relation is very different information it is, and I think we can put it where it's here. So this side relation, and this is relation, and you can say we remove this, of course. This is relation. These two relations are very important. This is relation number 1, and on diameter this relation number 2. This is number of earths in sun. And you may say, for better understanding, we can round it both, and we can round it both here, and we say so it's increasing, we say it's like that. So this and this we accept like this, that 111 earths are required to complete to reach whole diameter. But when you say volume of sun and volume of earth, if you compare, you need 438,652 earths, 438,652 earths, or you can say 0.44 million earths must be there to dip in to make a sun. You can understand this point easily. This is nothing very specific. And similarly, you can find other values, but sun and earth relations are very important. That's why I put in there. So I think this is additional I've done for statistical purpose. So 111 number is coming for diameter of earth equal to sun, and 0.439 million. 0.439 million earths are required to make sun. Right? This is what Excel or your worksheet can do. This is a very interesting one, and I think you got it, you enjoyed it. It's very important point, and exclusively I wanted to devote this talk, this video to solar system, and not to include something else, because this is very specific calculation, and though it's not directly related to civil engineering execution, but astronomical, which I studied in surveying astronomical calculations. Astronomy is a kind of part of astronomy. This is part of study of astronomy, which is also very, very important for engineers to understand, because after all, civil engineer means Brahman engineer, earth engineer, all planet engineer. But it's in imagination, it is in, I can say, hypothetication, I can say hypo study. It's not far from imagination, but it's also near reality. Reality it is, and I think I am. I hope I am successful in communicating to you what was required. That's the important point. What we understand, what we want to communicate, what we can do, that should be done successfully and correctly. Maybe I made some mistake, I cannot say at this stage, but yes, if you go in depth study of that this video, you may help me or help yourself to correct this. But I think, as far as I understand, this you should not forget some important information here. And the information is you should remember that Earth's axial speed is 1636, which means we are moving at a speed of 1636 in air or on surface of Earth kilometer per hour, and this is 1.08 million. I'm sorry, this is 1.08 lakhs, 1.08 lakhs kilometer or 0.18 million kilometer per hour. 1.18 0.108 kilometer million kilometer per hour, or 1.07 lakhs kilometer per hour. We are moving around sun, and this is volume of Earth, and this is something else that's not very important study, but this study you should remember part of general knowledge about, because we are moving around double speed of international flight, and we are moving supersonic speed, and we are here using imaginary, there is no vehicle here. Even Earth reaches, if Earth reaches sun, just think Earth won't appear again, it will disappear, because 2.5 million kilometers required, and there was no one here. If all these planets reach by mistake in vicinity of sun, all planets would disappear, only sun would stay. This very important point, you got me. As I said, if some rocket is launched from surface of Earth by evil mind, and then it's programmed as to come back from space and hit sun and hits Earth again, Earth would disappear. Similarly, if these planets reach Earth, imagination, reach sun, none of them would appear, they will disappear. There's no such planet so far that can face sun. That's why these are millions and millions of kilometers away from sun. And as I said, this is what you remember, that 111 Earths are required. 111 Earths are required to make one diameter of sun, and 438,652 Earths are required to make one sun. This is very important information. Keep in mind. This is this worksheet, value that you are getting by knowing. And also I see if I can change something else here. I cannot do anything except here, because I not put anything of mine. It's not formalized except title. So sun and earth, volume, and this is a diameter. So it's okay. Here I can say Earth's numbers and sun. So volume of Earth, I can say here, I can write rather than this. I can say, let's put one here better for clarification. You can say volume, sun volume. I can say sun volume divided by earth volume. Sun volume divided by earth volume is Earth's number in sun. That's important information. So we make it like this, that this is one part, of information, and this is another part of information. Both are equally good. You can say both are equally good, and I should rather say that. Okay, no problem. So this is sun volume or earth volume. I should not keep it bold. I keep it like this, because this also I keep it like this. Is that actually I had taken this one as border, but it happened something else. So it's like this. I think I have done size relation. So you remember this, and don't remember this. Just keep it down so that it's clear. These are important points here, and this is what is to be done. You got it now. These parameters we are using here, these are very, very important parameters now for us, for civil engineers and for others. And I think now already 1.5 hours passed, and I'm not left with anything, and I don't include something else in this particular volume of the video, because I want to devote it to solar system today. So my dear friends, I promise you I have done it today, and I'm going to close it now. For time being. It may be 1 hour 31 minutes or 1 hour, whatever it is, since I try to give my best to you for Excel. There's so much left, so much material left, but general material I have given to you. Other is engineering material, engineering designs, which you only, but links I will explain to you. This Carney's theorem I will explain to you in one talk, though you may not understand that if you are not an engineer. But my purpose is not that. My purpose is only to let you understand how closely links can be done, minutely closely, because it's like, atomic structure, cellular structure. That's more important rather than understanding engineering. Here I'm using very open links, very, very ordinary links, but there it's performable link. And that chart, that sheet I will explain to you maybe next one or some other time. I'll try to tell you what actually it is. How can we link in a complex way? There are so many ranges in that file, and I will try to give you a little about each formula I used. There will be hundreds and hundreds of links in that, and many complex formula. I will just try to give you an idea how to do best with this worksheet, and that's the sole purpose of that, nothing else. You're not related to Carney's theorem, you're not related to structural design, you're not related to theory of structure, but you are related to formula design. You are related to composition of formula, how to evolve formula, how to make application, so that if you have that complexity, you can use those formulas. That's sole purpose of that, nothing else, and that's my intention here. That was an exclusive intention that you get that information, and I feel pleased that I've given you most of these ordinary formula in tabulation form, or in some direct application, or in some free cell form, and also, as I gave you last time, boxes, etc. So wait for that complex sheets, maybe not one or many. I will also show certain foundation designs we use and how we connect them, and also means whatever possible. I'll give you whole complexity of calculation, because these calculations you won't find somewhere else in box of worksheet. Not possible. I'm not interested in graphics, I'm not interested in data, and I think you too of having same thought. Why to waste time? This worksheet is very important tool for calculation, and this used in backup of other designs which are not exposed, but this is linked to that one. The basics are same, and only ways how to utilize this sheet to your requirement. And not necessarily it's a part of your job, but you understanding is more important. It doesn't matter what type of architecture on this one you use, or what type of, keep on moving from whatever you do, and you can change anytime, because copy paste cannot be changed. But when you cut it, cut paste doesn't affect anything. You got my point. If you copy paste, it affects. If you copy paste, it makes a difference when you change it or you change cell. But when you cut and paste in Excel or in Lotus, cell is not affected. Whatever address of that cell is, row and column, and where you move it, automatically that address is changed. So if you cut and sew, when you make some, even though you don't feel happy with that formula, you can shift cells here and there, so that you can see every cell comfortably, and you can in future remember everything what you did with that. That's also a very important point. And if you can understand that, means there could be hundreds of cells in formula which you want to remove, you can move them, no problem. But if it's copy and paste, that will change everything. That will remove all values if you will change them, because then you have to be very careful about that. But as far as cut is concerned, on cells you move wherever you cut, I mean to say move, cut and move, you won't change, won't affect, it shall be there, and it shall not lose its link as well. So that's very important information. I don't know whether or not you are getting it, but it's very, very important information. This is, you must understand that. It's very, very important information. Now I have given you, once again I move on this file, just when I just move on this file for your just for refreshing. You see what we have. It's very small file. I'm not making very big, but information is very different in this. And I read all text, etc. And also just now I worked out on number of earths and how many earths can equal volume of sun, and how many earths equal volume of sun diameter. That's really interesting one. 111 earth and 438,652 earths, and it's a big deal. Means if you want so many earths, it's big deal in universe. And I don't know how God's done it. God knows, only I can't say. So purpose is that we are not doing anything except trying to understand what is nature, how it works. Only my question always I raise to myself is, means so many million kilometers, or so many thousands of kilometers, these planets, for example Earth, this has 12,500 kilometers in diameter. If you consider the object or structure, it's not having any structural foundation, it's not having any structural anatomy, and still it's working. It has been working since, you can say, since this Earth was constructed along with solar system, and there's no accident, there's no collision, and still this solar system or other systems along with this solar system are safe. They're moving. If it is 15 crore kilometer from sun, means it is. There may be a slight difference, but it's not reaching sun. We cannot say today it is 15 crore kilometer, next month it will be 10 crore kilometer. That's not acceptable. It cannot happen like that. And that's beauty. Means how these 8 planets are always in equilibrium position, in static equilibrium as well as in dynamic equilibrium, as well as you can say orbital equilibrium, axial motion equilibrium, always. And they never fight together, they never collide together, and they remain distant, constant distance from sun. And there's no, what is structural equilibrium? God decided and designed and constructed. That's the important point. If you are scientists or engineers today, this earth is only, it's only 12,500 kilometer in diameter. You try 1 kilometer diameter and shoot it into space and balance it out. It's not possible. It's not going to work that way. That's impossible. That point is very, very, attraction container, you can say. And that's the only reason I try to get to you. This value means when we make a building or we make even small work, small element, we try to study analysis, we find structural details, we study soil, and then we say foundation is this, first one, and then we decide structure. But this is automatic, no beam, no column, no structure, and it's we think stationary, but these are all stationary. That's the beauty of this. Means dynamism, motion, rotational motion, axial motion, all these motions, keep them in equilibrium position. And if what happens, you see, this dynamism stops, I think everything would collapse. That's what I think. If dynamism stops, they will move in unknown directions, all these planets, and collide with each other. This is what I think. I can't claim this sun is there. These may move towards sun, or they may go there, or they collide with each other. Nobody knows what shall happen. So this is magic, you can say. It's a kind of orbital magic. It's a kind of universal magic that these objects and not solar system objects, all other systems objects are safe, and we only can calculate. We cannot see practically how many planets, how many solar systems are actually there. We can only imagine. We can just dream in. That's what calculations is fake. Just like I'm dreaming 111 Earths. It's a dream. I say so many millions, Earths can be contained in one sun, or one sun can contain how many Earths, and similarly our Jupiter, how many Jupiters, like that. And that's where the study is about. So I think you got my point, I want to say, because it's very interesting point. I think now it's enough for this sheet of explanation. I just wanted to know such itself means how these orbits, how do these orbits stay here and there all the time, don't fall. So they don't fall because of scientifically designed methods, and God knows only how they work, and from where this physical material might have been imported, or how could energy be converted to this material. I can't answer. How could this energy which is available from sun otherwise, and even sun, how it was constructed, I cannot say. I don't know. And from where energy came, energy was procured, I don't know. Only God knows from where procured and installed after construction of these, or on in situ construction it was for every planet, or factory construction, I can't say. So it is such a wonderful arrangement. We never looked into that direction. We looked only on Earth, how gravity is working on Earth, or how negative forces are working in space, vacuum, you can say. Not more than that. We had an idea. Really, it's wonderful. I can't explain, I can't express. What is engineering is not answering that. Soul engineering is not able to answer that. How could be done? Though we say we are engineers, we are constructors, we are builders and promoters and designers, we say. And we are very complex in our working, our small, very, very, very small designs. We don't know even about Earth, but lithosphere we are not sure. We don't know how seas were formed, and we don't know how this universe was formed, and we don't know how these planets are constructed and located in various positions. So that's beauty of universe, and universe is wonderful, you can say that way. So I say, nothing else to say in that. That's because actually it is very, very wonderful. No one can say no. If somebody tries to say no, I think that person is itself wrong. And you know, volume, you see, volume is just imaginary. You see how much is volume. That's point I could not discuss with you. You see volume here. This is speed, okay, fine. We see density is there. You see volume here. You know, say for example, volume. This is here, and you know, total volume. I think I didn't calculate that one right. Well, doesn't matter. This is a volume. We can see. This is volume and total volume, and this is volume of each planet. And if I say what to do with it, how to find volume, means I think there's no cell here, so what should I do? We can check it. I just put, for example, I just put in here one cell here, just for reference I'm showing. Means here I say add some, you know, add some here, and I sum up for it. I sum up from here. This range 1, 2, 3, 4, 5, 6, 7, 8, 9. I sum up this, I will get volume there. So you can say this is volume here, 2.5 into the power 15 cubic kilometer, and the volume here is for all planets. And also you can say propulsion force and centrifugal force, and let's say total force which these are carrying, that is in N you can say. So I can simply say here that if I copy this here to this propulsion force, you'll get propulsion force here 5.31 E plus 28, and centrifugal force similarly you can just put in here, can get centrifugal force here. So we can say, just I extended this, and for your information only, this is here. So this one is very important one. And also how many times propulsion force, this is the number that you can, that does not matter anything. And this is here. And self-planetary relation, we have taken this, the no need of planet distance, that doesn't mean planet surface area. Planet surface area, that's also an important point. So we can say, okay, I copy it here, planet surface area, total area is that, because we say volume is there, so we must have surface area. So these are parameters that give some information, and I keep them here. Let's say 1, 2, 3, 4. So we say this is very important information, and here and here. So I put it here, all models, and this is the one. So I say this is very specific information, but here now I close with this chart here, so that this is isolated from that one. You can say, so this is here very, very separate, and this information is specific. Here I can say specific information. You may say specific information here. This is specific information. Specific information. Here this, you know, information, the specific one. So you may say this is up to here, and up to you can say here, and also here. So leave it as it is, no problem. So this is specific information, and you can say sum. I can say, you can say sum. It is, you can say sum yourself, dynamic, and this is you know, sum of planetary force. And so when you see that, you will find this answer automatically. So I remember, I just recall my and did this. So this is specific information. You can use that one. Now, of course, what else, you know, on this sheet you can see other than this is also very important. You know, I have given right now solar system envelope coverage, and all this I given here. That's important information. So all this we have percent of solid space, also volume of solid sphere, volume of solids sphere. So we have taken that into consideration. And illumination of course is there. There's no problem. And proportion force, and also this information is that's that's here. This is number of solar systems. You can say this is also as this is S15. So already is there. So I can't take in there. You can take somewhere else. I'll just keep it highlighted so that you should not find it again where it is. So this is here, number of solar systems. Yeah, it's here. This we can highlight it, and so that we can remember it. This very important point here. So this information we got in, and we also highlight this as well, so that people should understand why there's some specific purpose. You highlight something, and that means projection, and it's this one. So you can say specific information, and this is the one. Well, I think I don't know if I keep on talking, I'll get more and more information in my mind, and time will go on moving. Well, I think it's okay. I think it's okay, and we can say that. Well, I think you'll appreciate my efforts I'm doing here. It's not question of time. Time moves on and on. We know. It's question of what you do. So, as I said, I tried to assimilate information into small sheet, and this is solar system parameter sheet. You can say, you can talk with your friends, and you can talk to your kids if you have, and you can contemplate on this, you can think on this, and you can say it's like a system. Means I have given the system information, and this system information is very much particular, and only, I mean, they may say, some of you may say this person is getting crazy because he has nothing to do with this. He's a dust engineer, or is a soil engineer, I can say dirty engineer, because he's a civil engineer, and civil engineers are always dirty. They don't care for their personality, and they don't care for the ties and suits and beautiful cars and clean cars, and like that it happens. It doesn't matter. But this must be from scientific departments, this must be from a space department, someone else. But ना फिर ना बोल दिया उधर, हाँ 12 बजे बोल दिया ना उसको, बंटी को बोल दो, फिर वो कहीं लग जाएगा, 12-2 बजे तक वापस आ जाएंगे ना फिर. So I just showed to you notes again in projection, in blow up, so that you can read them yourself, because time is short, it's going to be near 2 hours. And I explained, in beginning I spoke, and now I have whatever work I did during this talk, whatever modifications I made, editing I did, it's all for during talk improvising, and is useful. This time I say that I have also some files giving specific work, but this time I'm giving you direct file. I last time recorded solar system, but I spoke only. This time I am giving you file projection, which is very much important. You can view this file. If you want to download this file, you can get complete information. I don't think you will need original file, because I'm not put on any website, because it's sometimes very difficult to put Excel. There's only one, is script.com which accepts some files, but Excel files I'm finding sometimes very difficult. I had many files I tried to put in, I could not do that. These Excel files there, so they could download from there. So it's really what file they take, or some of the file, even sometimes PowerPoints they cannot take, and that's only problem. So I try to use this in like.com, this function share screen or screen share, so that I could discuss certain files with you. But only limitation there is, restriction there is, that you cannot change files in same talk. Means if I'm talking on Excel, I can discuss on whatever number of Excel files. If I'm talking words, I can discuss Word files, or means you have to take only one format. Means either Excel you take, or PDF you take, or take more other, even drawings you can take, or you can take even you cannot take projection of internet. Means if I take some website here and do that, I can't do that. That's not permissible. That's problem in such, well, whatever. I'm not saying the perfect application by Facebook, but at least they are giving live chance, which other YouTube too gives live chance, but restriction on YouTube is you can't share screen, or you use camera, second camera, or you use projection for something else. So that much I can't do. I don't have that resources with me. I am having only one laptop, and I use that for purpose of video, and I prefer live, because it's better to do live to save time. Because if I record and then upload, it takes double time, and you cannot guarantee. But here, whatever is saved is saved. So I can't keep copy of that one, because I don't have yet. Purpose is solved. Copying is not my purpose. Purpose is information dissemination, which is requirement of studies and knowledge. And if you can do that, it's very, very fine. And that's what I say. I did it today. Very specific. I shared with you very specific information. Till now, I moved around before this file. on calculation formula or either nature, but this is very enormous. This is beyond imagination. This is a complete expanded mathematics, you can say. We are not talking in centimeters and meters or on kilometers. We are talking in millions and crores kilometers, you understand? Crores and crores kilometers cube, crores and crores kilometers square. That's difference in this, only difference, because we are talking solar system and we are talking 10 to the power 23, 10 to the power 25, like that. 10 to the power 37 means how many zeros you use. Sometimes I wish people like that, millennium time basis. When there's maybe, I don't know, they got it, but millennium, MILLION, millennium is 10 to the power 3003. Similarly, you can say 10 to the power 27, I think, is octallion. Octallion, OCTALLION. Octallion is 10 to the power 27. Such units are miraculous, very, very important one in engineering. So I think I think I have done something. I've done something for you people today, scientifically and engineering wise, and really it is you can say it is miraculous that if you can understand and think on this. Thinking is your responsibility, concentration is your responsibility, it's not my responsibility. What I could concentrate, I've done it, collected information, took time, you invested time, and projected to you in a precise way. How can we think? Purpose is that. It's not that this solar system is right or not right. I'm not worried about that. That's not my job. My purpose is, can I mathematically communicate with people how to do it on this transmission sheet? This is a kind of method of communication, and that's where I was interested in. Now it's already crossed 2 hours. I think I should wind up this video now and talk of something else if I have time during afternoon or evening. Without other file, I'll share it later on, because I don't want to bore you. I'll talk something about engineering and management or organization and quality, and that in a common way. That would solve my purpose, and that's, can say, is more important also, because I talk to you this, because I start showing kindness. File is very long one. I think I'm not able to do today, because I want to talk in different tone, in scientific and engineering tone. And you can say today morning also I included something on COVID-19. So like that, it's very important point. We should understand such points, and that's where we stand for. Now I'm waiting just for 1 or 2 minutes so that I take 331 stove